Welcome back. Thank you for joining me for our second day of arithmetic sequences notes. So today we're moving on to a new topic. So yesterday we talked about how to write these formulas to find a future term. Now that was when we were given sequential terms of the sequence. Now what happens if we're given some terms out of order? Okay, so look at this one. What are the second and third terms of the arithmetic sequence? Well, the problem here is we're not given two terms in a row. That makes it more difficult to find that D, that common difference. So what we're going to have to do is we're going to have to use those missing terms and plug in what we know to that explicit formula, which I put in your notes right there, and use that to find that common difference. So here, let's take a look. We have A1, we're missing A2 and A3, and we're given A4. Okay, so again, let's plug in what we know. So we know that A to the 4. So we know 82 is going to equal A1, which is 100, plus, now here that n minus 1, well, we know we're talking about 4. So 4 minus 1 times D. So really we're plugging in a to the n and A1 in order to find D this time. A little bit different than what we've done before. So 82 equals 100 plus 3D. And once you plug in that information, well, now all you're doing is solving a linear equation. So I'm going to subtract 100 from both sides, then divide by 3. So I'm getting that D is -6. So basically what that's communicating to me is I'm subtracting 6 from every term. All right, so if I want to fill in those missing terms, well, all I do is take 100 minus 6. That will give me 94. Minus 6 again, 88. And then minus 6 again, just to make sure you land where you should. And that does give you 82. So that's our strategy here, using that A1, A4, and the fact that we know what n we're talking about in order to get that common difference. So let's try it again. So we have A to the 1. We're missing A2 and A3, and we're given A4. So let's plug everything in to make sure that this, or to see how this plays out. So A4 is 125. And that equals A1, which is 80, plus n minus 1. Well, 4 minus 1 times D. So we end up with a linear equation again. And how do we solve linear equations? Well, we subtract off that 80. So we get 45 equals 3D. Divide both sides by 3. And we get that that common difference is 15. So that common difference of 15, what that means is I'm adding 15 between every term. So I come back up here, 80 plus 15 will give me 95. Plus 15 again is 110. And then make sure when you add 15 again, you actually get the 125. And you do, so that means we are done and we've solved this problem. All right. So now these types of problems can present themselves in another way too. So they can give us, if A1 is 6 and A5 is 18, what is A13? So instead of finding the missing terms in between, we can find the future terms. However, the setup is still actually exactly the same. So A5 is 18. We're going to set up our explicit formula, equals A1, which is 6, plus n minus 1. Well, this time we're dealing with 5. So 5 minus 1 times d. So we're going to use this to find that common difference. So 18 is equal to 6 plus 5 minus 1 is 4. So 4d. And again, linear equation. Hopefully we know how to solve these. Minus 6 from both sides. Divide by 4. So we're getting a common difference of 3. Okay, so now we have that common difference. But this time, we're not looking for one of the missing terms within that range. We're looking for a future term. Now, recall from yesterday, in order to find future terms, we need that explicit formula. Okay, so we're going to rewrite a general explicit formula rule. So, a to the 1 plus n minus 1 times d, which we now know is 3. So now that we have our general explicit formula, now that I want to know what a to the 13 is, all I have to do is plug in 13, and I'm golden. So 6 plus 12 times 3, type that into the calculator, and you get the a to the 13 is 42. All right, so we're going to be moving on to the next page. So if you need to, please pause it so you can finish writing some of this down. Now, another concept is arithmetic mean or arithmetic average of two numbers. And you follow that formula. So basically, you're just finding the average of the two numbers. Add up to the two numbers divided by 2. That is what we call the arithmetic mean. So in an arithmetic sequence, the middle term of any 3 consecutive terms is the arithmetic mean of the other 2 terms. So what that means is if you're missing a term that's in between 2 other terms in a row, you can use the arithmetic mean to find that missing term. Okay, so for example, this next one, use the arithmetic mean to find the missing term of the sequence. Because you have 3 terms in a row and you're missing the middle one, all you have to do is take those 2 terms and average them. So 15 plus 59 is 74. 74 divided by 2, 37. Boom. Done. So that's all you have to do for these. If you're just looking for a term in between 2 other terms, just use the arithmetic mean, and that'll find that term for you. A little shortcut, so you don't have to go through all of that formula work in order to get your answer. Let's take a look at this one. The 9th and 11th terms of an arithmetic sequence are 132 and 98. Use the arithmetic mean to find the 10th term. So we have 132, our missing term, and 98. So again, instead of going through all of that work using the formula and stuff like that, you're just missing a middle term of 3 consecutive terms. All you have to do, find that arithmetic mean. Average the 2 numbers, 132 plus 98. That gives you 230 divided by 2. Your missing term is 115. And that's literally all that you have to do. Now again, remember, this only works if you have 3 consecutive terms. If that gap is bigger, you can't use the arithmetic mean. Okay? So this only works with 3 numbers in a row. All right, so this one I was able to keep pretty short. So thank you for joining me for this video. Please make sure you have everything written down and then come back prepared to begin your practice work.